Welcome to Vision Mathematics. My name is Thomas Wanda, and I'm going to take you through the lesson on this video. Lesson number 8, Trigonometric Equations. In this section, we are going to be looking at equations involving the use of compound angle and or double angle formulae. Example number 1. Solve for x. 4 sine x cos x equal to minus the square root of 2. We observe here that sine x cos x suggests that we may be able to use the double angle formula for sine x. The challenge here is 4 here. We need a 2 here. So we must split this 4 into 2 times 2. So that's 2 multiplied by 2 sine x cos x. Then this can be replaced by sine 2x. So we have 2 sine 2x equal to minus the square root of 2. And dividing both sides by 2, we obtain sine 2x equal to minus the square root of 2 all over 2. Next we find the reference angle from our calculator. Remember, when you are finding the reference angle, you ignore the minus sign. So the reference angle is sine inverse square root of 2 over 2, which gives us 45 degrees. Then going back to the sign, the negative sign here, we remember that the sine function is negative in the third and fourth quadrants. That is where it is negative. So that is where our solutions lie. So first, looking at the one in the third quadrant, we have 2x equal to 180 degrees plus 45 plus k multiplied by 360 degrees, where k is an integer. 360 degrees because the period of the sine function is 360 degrees. Then 2x equal to, simplifying that, 180 plus 45, 225 degrees plus k times 360 degrees. And finally dividing by 2, we obtain x equal to 112.5 degrees plus k times 180 degrees is the general solution. Then looking at the other quadrant, which is the fourth quadrant, in the fourth quadrant, 2x is equal to 360 degrees minus the reference angle 45 degrees plus k times 360 degrees. That gives 2x equal to 315 degrees plus k times 360 degrees. And dividing by 2, we obtain the final general solution as x equal to 157.5 degrees plus k times 180 degrees. Example 2. Solve sine 5x cos 3x minus cos 5x sine 3x equals to 0.6. So that's our equation. Looking closely at the equation, we see that this is the right hand side of the compound angle formula for sine. It's like sine A cos B minus cos A sine B. So we apply the compound angle formula in reverse, which says we must subtract the angles. So we have sine 5x minus 3x equal to 0.6. And simplifying the contents of the brackets, we have sine 2x equal to 0.6. Then we find the reference angle. From the calculator, the reference angle is 36.87 degrees. Then the sine function is positive in the first and second quadrant. So beginning with the first quadrant, in the first quadrant the solution is equal to the reference angle itself. So writing down the general solution, we have 2x equal to 36,87 degrees plus k times 360 degrees, where k is an integer. Then dividing both sides by 2, we obtain the general solution as x equal to 18,43 degrees plus k times 180 degrees. Then we move to the second quadrant. In the second quadrant, 2x is equal to 180 minus the reference angle 36,87 plus k times 360 degrees. Then subtracting here, we have 2x equal to 143,13 degrees plus k times 360 degrees. And then dividing through by 2, we obtain the answer x equal to 71,57 degrees plus k times 180 degrees. Example number 3. Solve cos 2x equal to 1 minus sine x. Studying the equation, we observe that the one which is easy to substitute for is cos 2x, and it is the one which has formula which have 3 alternatives. Now we'll be guided by that, because in equations it helps to have the equation in only one function. So we want the equation to be in sine x only, so we will choose the formula for cos 2x which involves the sine function only. And that is 1 minus 2 sine squared x equal to 1 minus sine x. And taking these two across to the right, we have 0 on the left. This minus 2 sine squared x goes across to the right to get 2 sine squared x plus 1. Then this across to the right becomes minus 1. Then minus sine x. Then plus 1 minus 1 is 0. That leaves us with 2 sine squared x minus sine x. Taking out a common factor sine x, 0 equal to sine x into 2 sine x minus 1. That means either sine x equal to 0 or sine x equal to half. Now from sine x equal to 0, the calculator will give you x equal to 0. But if you know the graph of the sine function very well, it will cross the x-axis at 0 and at 180 and at 360, which shows that sine x is 0 at intervals of 180 degrees, not 360. So x is equal to 0 plus k times 180 degrees, which is just k times 180 degrees. That is from this one. Of course, k is an element of z. Then from the second one, sine x equal to half. This is positive, and the reference angle gives one of the solutions. That's in the first quadrant, which is 30 degrees. So x is equal to 30 degrees plus k times 360 degrees. The other one will be in the second quadrant. So in the second quadrant, x is equal to 180 minus the reference angle 30 degrees plus k times 360 degrees, which simplifies to x equal to 150 degrees plus k times 360 degrees. Example number 4. Solve cos 2x equal to 3 cos x plus 1. Now in this equation we observe that Here on the left hand side we have cos 2x, while on the right hand side we have cos x. So we have to express cos 2x in terms of just cos x. We make use of the double angle formula, and to avoid bringing in another function sine, we choose the double angle formula for cos x, which involves only cosine, and that is 2 cos squared x minus 1. So replacing cos 2x with 2 cos squared x minus 1, then taking 3 cos x plus 1 across to the left hand side, they will be minus 3 cos x minus 1 equal to 0. Then collecting like terms, minus 1 gives us minus 2 here, and rearranging we have 2 cos squared x minus 3 cos x minus 2 equal to 0. Now this is a quadratic in cos x, so factorizing, the factors are 2 cos x plus 1 into cos x minus 2. After factorizing, you should quickly check your factors by multiplying out to see that they give you the original. No need to lose marks. Then from the first factor, we have cos x equal to minus half. From the second factor, cos x equal to 2. Now this one has no solution. I think we remember that the graph of cos x oscillates between minus 1 and 1. So this one has no solution. It is important that you indicate that there is no solution here. Then from the first one, we find the reference angle. From the calculator, the reference angle is 60 degrees. And this is a special angle. You can even tell without using a calculator that the reference angle is 60 degrees if you have been working with special angles without a calculator. Then we go back to the sine. Cosine is negative, and it is negative in the second quadrant. So our solution, x equal to, remembering that the cosine function is an even function, so there is no need to take the other solution which is in the third quadrant. We just use one solution and put plus or minus because it's an even function. This will cover the solution which is in the third quadrant. So that's plus or minus 180 minus the reference angle 60 plus k times the period of the cosine function, 360 degrees, where k is an integer. And simplifying the subtraction here, we obtain our general solution, x equal to plus or minus 120 degrees plus k times 360. Let's now look at the suggested answers. Question number 1, cos 2x plus cos x plus 1 equal to 0 for x lying between minus 180 degrees and 180 degrees inclusive. Since we have cos 2x here, we can substitute using a double angle formula. Remember, this is the one where you have three alternatives. Guided by cos x here, we choose the one which has cos only so that we maintain one trig function in the equation. That's replacing cos 2x with 2 cos squared x minus 1, then plus cos x plus 1 equal to 0. Then minus 1 plus 1 is 0, and that leaves us with 2 cos squared x plus cos x. Observing that there is a common factor, we factor out cos x. That's cos x into 2 cos x plus 1 equal to 0, which gives us either x equal to 0 or cos x equal to minus half. Then considering cos x equal to 0 first, reference angle from the calculator is 90 degrees. And remembering the graph of the basic cosine function, it crosses the x-axis at intervals of 180 degrees, not 360. So our solution is x equal to 90 degrees plus k times 180 degrees. K, an integer. Then from the other equation, cos x equal to minus half. The reference angle is 60 degrees from the calculator. Observing that here cos x is negative. It is negative in the second quadrant and the third quadrant. So that's where our solutions come from. But we can write it as 1 using plus or minus, as cosine is an even function. So that's x equal to plus or minus 180 degrees minus 60 degrees. That's the second quadrant solution, plus k times 360 degrees. And simplifying that, we get x equal to plus or minus 120 degrees plus k times 360 degrees. Now we have the general solutions. We want to find the specific solutions which fall in the given domain, minus 180 degrees to 180 degrees. We find these by substituting for k, starting with k equal to 0, k equal to 1, k equal to minus 1, and so on, until we get values which all get off the given domain. We find that the solutions which will fall within the given domain are minus 120 degrees, minus 90 degrees, 90 degrees, and 120 degrees. The learner is advised to actually work out the solutions and see how they come out. Question number 2, cos 2x plus cos x equal to 0. Just like the first one, we choose to use the double angle formula, which is cos squared, so that we have only one trig function in the equation. So that's 2 cos squared x minus 1 plus cos x equal to 0. That gives us 2 cos squared x plus cos x minus 1 equal to 0 on rearranging. And this is a quadratic in cos x. Then we factorize. The factors are 2 cos x minus 1 into cos x plus 1 equal to 0. Giving us from this one cos x equal to half, and from this one cos x equal to minus half. Then from from x equal to half, cos x equal to half, the reference angle is 60 degrees. Then the solution is x equal to plus or minus 60 degrees plus k times 360 degrees, k an integer. Then from the other one, cos x equal to minus 1, we obtain x equal to plus or minus 180 degrees plus k times 360 degrees. Observe that in the interval 0 to 360 degrees, cos x is minus 1 at only one value, which is 180 degrees. Question 3. Cos 2x minus 4 sin x plus 5 equal to 0. Now here we observe two things. The first one is we have a double angle here, whereas here it's not a double angle. So we must get rid of the 2x. The other thing is that we have two trig functions, cosine and sine. We must express the equation in only one. Now since we can make a substitution here using double angle formula and we have options, we choose the one which has sine only so that we create one trig function. So we choose the double angle formula for cos 2x, 1 minus 2 sine squared x. So substituting for cos 2x, that's 1 minus 2 sine squared x minus 4 sine x plus 5 equal to 0. And collecting like terms, this 1 plus 5 gives us plus 6 here. So that we have minus 2 sine squared x minus 4 sine x plus 6 equal to 0. Then on dividing through by minus 2, the equation simplifies to sine squared x plus 2 sine x minus 3 equal to 0. This is a quadratic in sine x. We factorize the left hand side. The factors are sine x plus 3 into sine x minus 1 equal to 0. Then from the first factor we have sine x equal to minus 3, and this one has no solution since the graph of sine x lies between minus 1 and 1. Then the second one, this one, we get sine x equal to 1. Now having a look at the graph of sine x between 0 and 360, which covers the 4 quadrants, we see that sine x is 1 at 90 degrees only throughout. So there is only one solution between 0 and 360, and we use that one to write the general solution. So that's the general solution is x equal to 90 degrees plus k times 360 degrees, where k is an integer. Number 4, sine 2x plus cos 2x minus 1 equal to 0. Here we have two double angles in both functions, sine 2x and cos 2x. Now we have to try and think carefully how we are going to substitute for this one, because this one will give us both functions, sine x and cos x. There is no alternative. So here, if we choose the one which has a positive 1, it will remove this negative 1 so that there will be 0. So we try that one. It might simplify the equation for us. So sine 2x is 2 sine x cos x, and cos 2x is 1 minus 2 sine squared x, choosing the one which has a positive 1 here, so that it will remove that one. Then plus 1 minus 1 is 0. Then we are remaining with the 2 sine x cos x minus 2 sine squared x equal to 0. Now there is a common factor, sine x, 2 sine x So factoring out 2 sine x, here you remain with cos x, and here you remain with sine x. It's equal to 0. Then from this we get sine x equal to 0, and from this one we get sine x equal to cos x. Now in this type of equation, where you have sine and cosine and the angle is exactly the same, x, you create tangent by dividing by cosine. So dividing both sides by cosine, the right hand side will be 1, the left hand side will be sine x over cos x. We quickly note that the denominator must not be 0, so that the fraction is still defined. Then this is tan x, so tan x is equal to 1. Then we have these two from which to get our solutions. From sine x equal to 0, we have solved such an equation before. Sine x is 0 at 180 degree intervals. That's sine x is 0 here, and here, and here. Clearly it's 180 degree intervals. So we have our solution as x equal to k times 180 degrees. Reference angle being 0, so 0 plus that is just that. Then from the other one, tan x equal to 1, we have a reference angle as 45 degrees, and this is a special angle. I think we need to know this even without a calculator than tan x. If tan x equal to 1, then x is equal to 45 degrees. So x equal to 45 degrees plus k times 180 degrees. Remember the period of the tan function is 180 degrees. And don't forget k is an integer. Here we don't need to look for two solutions because tangent is positive in quadrants which are diametrically opposite to each other. In other words, they differ by 180. So the solutions in one of the quadrant covers the solution in the other quadrant. So you need only one solution if it is a tangent equation. Question number 5. Sine 2x equal to cos x cos 30 degrees plus sine x sine 30 degrees. Now, looking closely at the right hand side, which looks complex, we see that it is quite familiar. It's cos A cos B plus sine A sine B, which is the right hand side of one of the compound angle formula for cosine. Remember, this one is the one where we have to subtract the angles. So using the compound angle formula, we have sine 2x equal to cos x minus 30 degrees. Now the functions are different. Here we have sine, here we have cos. We can change this one to sine using co-angles. Thus we have sine 2x equal to sine 90 minus x minus 30 degrees. Observe the use of brackets here, because we are subtracting the whole of that from 90. Then we clear the brackets later. That's sine 2x equal to sine 90 minus this negative, and that negative will make a positive there. So plus 30 degrees, and adding 90 and 30, we have sine 2x equal to sine 120 degrees minus x. Now, if the functions are the same, then the angles must be equal. But then they keep repeating because this is a periodic function. So our solution, 2x equal to 120 degrees minus x plus k times 360 degrees, where k is an integer. Then taking minus x across to the left, we have 2x plus x, giving us 3x equal to 120 degrees plus k times 360 degrees. And dividing through by 3, we obtain the simplified general solution as x equal to 40 degrees plus k times 120 degrees. Then we have to find the other solution in the second quadrant. In the second quadrant, 2x is equal to 180 minus our reference angle 120 minus x plus k times 360 degrees. Then removing brackets here, this negative and that negative will make a positive. So we have 2x equal to 180 degrees minus 120 degrees plus x plus k times 360. Then taking plus x across to the left and subtracting here, we obtain x equal to 60 degrees plus k times 360 degrees. This marks the end of this lesson. Thank you for watching and goodbye.
Jesus.